For most of 2024, the consensus was that building a world-class artificial intelligence required two massive, highly restricted bottlenecks. First, you need colossal physical infrastructure, massive data centers packed with specialized hardware. Second, you need human capital. That human element is the most expensive line item in modern AI development. To teach a model how to think, you have to hire thousands of mathematicians, programmers, and doctors to manually write out step-by-step solutions to hard problems. The AI learns by mimicking their logic. To protect these assets, the US government built a regulatory wall. They implemented strict export controls designed to prevent the advanced chips required for AI, the forbidden silicon powering the frontier, from ever reaching Chinese soil. But in February 2026, the AI company Anthropic published a threat disclosure that shattered those assumptions. They exposed 3 Chinese AI labs, DeepSeek, Renshot AI, and Minimax, running coordinated campaigns to extract the reasoning capabilities of Anthropic's flagship model, Claude. The numbers show a massive operational discipline. The attackers used roughly 24,000 fraudulent accounts to generate more than 16 million exchanges with Claude, specifically engineered to harvest the model's cognitive patterns. This evidence suggests that framing the competition in terms of months or years is a mistake. These labs are exactly as far behind as the latency of a residential proxy and the upload time of a stolen dataset. The United States constructed physical and economic barriers to secure its position. Adversaries bypassed both simultaneously through a strategy that essentially treats American research as a public utility, the Rent and Distill Playbook. The Rent and Distill Playbook operates in 2 parallel pipelines. The first pipeline acquires the intelligence. It begins with a base ingredient, a strong, freely available open-weight foundation model like Llama 3 or Qwen. On their own, these models lack high-level complex reasoning. This illustrates the siphon attack. Instead of paying human experts to produce logic traces, attackers use an automated script to prompt Claude to solve hard problems. They force the model to show its work, narrating exactly how it reached its answer. Those reasoning traces are captured and compiled into a golden dataset. That data is then fed into the smaller base model through behavioral cloning. The student model doesn't discover how to solve a problem. It memorizes the shape of Claude's thought process until the mimicry becomes its own. To manage 16 million exchanges without triggering a ban, the attackers relied on a sophisticated evasion layer, residential proxy networks worldwide. Here, we can trace how a proxy launders identity. A request originating in Shenzhen routes through the home Wi-Fi router of an unsuspecting Comcast subscriber in Ohio or a Deutsche Telekom customer in Bavaria. When it reaches Anthropic's data center, it looks like genuine human traffic from a local user. Traditional defenses like geo-blocking are useless against this. It forces defenders into the expensive, reactive position of behavioral fingerprinting, trying to detect the specific patterns of a distillation attack hidden within millions of legitimate sessions. Through this pipeline, an adversary can fully ingest the cognitive value of a Western lab's billion-dollar research investment for the price of a few million API calls. Extracting a reasoning dataset provides the blueprint for the model, but turning that data into a competitive tool requires the physical power to process it. This is where the second pipeline begins, acquiring the restricted graphics processing units. This reveals a gap in the regulatory regime overseen by the Bureau of Industry and Security. While export controls focused on the physical shipment of goods, they largely ignored compute as a service, the ability to rent these chips over the internet. To exploit this, labs use offshore subsidiaries in jurisdictions like Singapore or the UAE. These shell companies sign legal cloud rental contracts with Western providers, acting as a middleman between the Chinese lab and the American silicon. The scale of this loophole is documented in billion-dollar contracts. Companies like Tencent and ByteDance have reportedly secured access to thousands of restricted Blackwell processors by virtually renting capacity through third-party providers. The hardware remains in a Western data center. The training effectively happens on US soil, and when the process is complete, only the final weights file, a set of numbers in a digital container, crosses the border back to China over a standard internet connection. The resulting Frankenstein model proves the US has been unwittingly hosting the very AI training runs its policies were designed to prevent. This creates an existential threat to US frontier labs. If a competitor can clone a model's intelligence for the cost of a few million API calls, the multi-billion-dollar cost of research is no longer a competitive moat. It is effectively a tariff that only the American innovator pays. In 2026, the U.S. government moved to close the compute loophole. The House passed the Remote Access Security Act with a nearly unanimous vote. RASA shifts the burden of national security to the cloud providers. If enacted, companies like AWS and Google Cloud would be liable for failing to identify when a Singapore-registered shell company is actually a proxy for a Chinese entity. However, RASA only addresses the compute pipeline. The first pipeline, the extraction of raw reasoning through API prompts, remains outside the scope of traditional export controls. This is a permanent asymmetry. A frontier AI model is an artifact that produces its most valuable training signal every time it answers a question. The more capable the model becomes, the more valuable each output becomes to a potential cloner. The final reality check is clear. Legislation can stop a physical microchip from crossing an ocean, but it has not yet found a way to stop pure intelligence from crossing the internet.